All right, good morning and welcome to Master Talker online class. Today we'll be talking about a topic called vectors. Okay, now what is a vector? First of all, let's talk about scalar. Okay, a scalar is a physical quantity which has only magnitude. When I mean magnitude, I mean the size. It has only magnitude but no direction. Okay, it does not have any direction. For example, you can say length. The length of something, there is no direction there. The mass of something or the weight of something, there is no direction there. Okay, time, there is no direction. Then speed, there is no direction. Okay, then let's talk about vector. A vector quantity is any quantity that has both size, which is magnitude, and direction. Okay, example is displacement, velocity, acceleration, force, etc. So many of them. Then the next thing we're going to talk about is vector representation. Vector representation. Now, how do you represent a vector? A vector quantity is represented by a line, just an arrow like this. That's how we represent it. Okay, the line, the length of this line shows the magnitude, the size of that vector. Okay, so if I say that this is vector A, this A here is the size, the magnitude. Then the arrow pointing where it is going shows the direction which that vector is going. Okay, so that is that. Then the next thing we're going to look at is addition of vector. Okay, addition of vector. Let's look at addition of vector. Addition of vectors. Now, how do you add a vector? It's very simple. Okay, where a vector is being added, two vectors A and B gives the third vector R, okay, which is called the resultant. How do we add a vector? If I have a vector like this, A, look at this vector now, A, this is vector A, okay, like this. Let me cap it, vector A. Now, if you want to add this vector A with another vector B, you are going to use, this is, here is the tail of this vector. Where the arrow is the head of the vector. Okay, to add another vector to this man, you are starting the tail of the second vector. We start from the head here. Okay, so this plus this is how to add it. Then the solution, the addition or the resultant, okay, is the third vector. Okay, the resultant is the third vector. And how do you represent it? We represent it by, you don't say the tail, adding the tail here. If you start from the tail to the head here, it means you are equally putting another vector. But if you want to get the resultant means the solution, the addition of the two of them. The tail of this one will join to the tail of the first one, and the head of this one will join to the head of this. So this is vector P. This is vector P, okay, and this is their resultant. Their resultant is called resultant vector. Their resultant is the solution, okay. So which means the resultant R is simply vector A plus what? Vector B. As simple as that. Okay? Vector A plus vector B. Let me give you an example. Let me give you an example so you understand what I'm saying. Okay? Find the resultant of vectors of vector B, which is equal to 10 Newton, okay, and vector Q, which is equal to 6 Newton, okay, as shown below. As shown below. Okay, now look at this now. If you have this vector, both of them, I'm having this. The first vector move this way. This is the first vector, 10, according to what they gave us, okay? And the second vector, 6. Okay, so the resultant will go in their middle. This is the resultant R. Okay, now since this vector are moving in the same direction, since they are moving in the same direction, their resultant is equal to simply 10 Newton plus 6 Newton, which is equal to what? 16 Newton. Okay, so but look at this vector now. Look at another one. But if this vector are moving in opposite direction, watch, Depends on how the question goes. So maybe I have this is the first vector, 10 Newton, okay, and the second vector moving in opposite direction, 6 Newton. Now, if they are moving in opposite direction, okay, the resultant moves in the direction of the higher one. So the resultant should go here. Okay, the resultant should be here. If you notice that the resultant, okay, I should make this one longer. This one's supposed to be longer. But this one is shorter because they are moving in an opposite direction. So the resultant here is simply what? The bigger one minus the smaller one. So I'm having what? 4 Newton. Okay? So, and the resultant of this vector is moving in the direction of the higher one. Because if I myself now and a small child is dragging a particular thing, maybe rope, okay, the resultant of the both of us dragging it in opposite direction, he's dragging the other way and I'm dragging the other way, I am going to pull him to myself. Why? Because I am stronger than him. The force I applied is bigger, so I'm going to draw him to myself. You see, so the resultant, what resulted was towards my direction. So the magnitude of the resultant is simply my power minus his own. That is what I use in drawing him to myself. You understand? So that is it. So, but if both of us are pushing it in the same direction, we will move higher. It will be his own. We are moving in the same. Even the resultant will move in the same direction. Why? Because all of us are going in the same direction. Okay, and the resultant is going to be what? Myself plus the boy. Okay, the power the guy used and the power myself used. Okay, as simple as that. So let's talk about the resultant of a vector. Resultant of vector. Resultant of vectors. Now we are going to talk about the resultant of two vectors in parallel and in perpendicular. Okay, if they are perpendicular and if they are parallel to each other. Okay, or do I call it parallel? Or let me say, no, not parallel, but let's talk about the one that is perpendicular. So if we have two vectors, for instance, now let me give you an example. Let me use an example to do that. If we have two vectors like this is vector A, okay, which is perpendicular to vector B. Perpendicular means they meet at angle 90. Okay, so they say that the resultant vector is from here to here. Okay, R, and this is B. Now, don't forget what to get this. Don't forget how to get this according to Pythagoras theorem. Pythagoras theorem say what? That r squared is equal, the hypotenuse squared is equal to what? Any of this side like a squared plus what? B squared. Okay, so as simple as that. That is for the two that are parallel to each other. Perpendicular to each other. So let me give an example to that. Example 1, I have find the resultant of the two vectors 3 Newton and 4 Newton. Okay, if they are at right angle to each other. Okay, so look at that. As simple as that. How do you do that? Let me show you. Let me show you now. So I have this. I have now the first one. They are at right angle. This is the first one, which is a 4 Newton. Okay, and the second one, which is a 3 Newton. Okay, their resultant move this way. This is their resultant R. So what do? You say that R squared is equal to what? 4 squared plus 3 squared. So what do? R squared is equal to what? 16 plus 9. So R squared is equal to what? 25. So R is equal to the square root of 25. So R is equal to what? 5 Newton. Okay, so as simple as that. We'll just apply Pythagoras theorem. Why? Because they are at right angle. Being at right angle means that they are perpendicular to each other. Okay, so that is that. Now let's talk about when they form the adjacent side of a parallelogram. When they form the adjacent side of a parallelogram. So resultant of two vectors that forms an adjacent side of a parallelogram. What do I mean by that? If the two vectors, the angle they form is not 90, maybe it's greater than 90 or less than 90, that is when we talk about, that's when we use the parallelogram law of vectors. Okay, whenever it is not equal to this 90, it is either less than 90 or greater than 90, then you use the parallelogram law of two vectors. So let's talk about that. Parallelogram law of vectors said that if two vectors are represented by two adjacent sides of a parallelogram, okay, that the resultant is equally represented in both magnitude and direction by the diagonal, okay, by the diagonal of that parallelogram. Okay, let me show you what they mean by that. Now I have two vectors like this. This is the first vector, okay, and this is the second vector. Now let me say they met at an angle theta. Okay, now if you look at this, now if I trace this one to this side, this particular one, this is vector A and vector B. Okay, if I trace vector B to this side, it will go like this. If I trace vector A to this side, it will go like this. If you look at this now, this is forming what? A parallelogram. Okay, they say that the resultant of these two vectors must move in their middle. It must form the diagonal of this parallelogram. This is the resultant of these two vectors. Okay, so if here is vector A, here should be vector A. Are you getting it now? Now if I decide to extend this like this, now there's something that is called adjacent angle. Okay, yes, adjacent angle, something like this. If you have like this, if you have a line like this and this move this way, okay, that this side is equal to this side, okay, it is called I think adjacent angle. Yes, I think that's what it's called. So watch it now. I'm having these two lines. Let me do it in the other way around so you understand. I'm having two lines like this and another one move like this. Okay, it shows that here, under here must be equal to under here. So under here, which is theta, must be equal to under here, which is theta. Are you getting it now? So for me to get this side, I will say that what? For me to get this side, I will say, because an angle on the straight line is 180. So if you remove this side, this side will be 180 minus theta. You see? So why do I need to get this? I need to form a triangle. Look at the triangle I want to form. Like this, and like this. Okay? And here is my A, here is my B, here is my what? 180 minus theta, and here is my R. Now, if you look at these two triangles, you can go to my video on trigonometry. Okay, if you want to, if two sides are given with an angle in between the two sides given, what we are going to use is called cosine rule. I taught that in trigonometry in my video. Okay, so using cosine rule to find my R, using cosine rule, it says what? That R squared is equal to, you start from here, A squared plus B squared minus 2 times the same A times the same B, then cos, that's R, cos the one facing this R, cos the angle facing that R, which is what? Cos 180 minus theta. So this is the formula for getting what? The resultant of two vectors that are less than 90 degrees. Okay, in fact, this is the formula for getting resultant of any vector, even if it is 90 degrees. Let us find the other one. Let us find, they say that the other one is what? 90 degrees. Let us find it using this. We want to find it using the same example, number 1. And they gave us that A is 3 Newton and B is equal to 4 Newton. Let us check what is going to give us. I'm going to have R squared is equal to 3 squared. 3 squared plus 4 squared minus 2 times the same 3 times the same 2, then cos what? 180 minus 90. Because they are at right angle, so theta will be 90. Because they are at right angle. So what do I have? This is R squared is equal to 9 plus what? 16 minus 2 times this 4 times this 12. So I'm having 12 cos what? 90. Now don't forget that cos 90 is what? Cos 90 is 0. So if cos 90 is 0, I'm having that r squared is equal to this plus 0. I'm having 25. So r is equal to the square root of what? 25. So r is equal to what? 5. You see, we got the same answer. So this is the formula. This formula is very important to find the what? The resultant of any two vector. This is the formula to find what? The resultant of what? Two vectors. So instead of cramming that if it is at right angle, you use Pythagoras and blah blah blah. So just know this formula. Okay? So let's take an example to that. Now, I have they say calculate the magnitude and direction, okay, just the magnitude. Okay, they say we should find just the magnitude. They said the magnitude, find the magnitude. We will still come to direction. They say find the magnitude of the resultant vectors of two vectors of magnitude 10 Newton and what? And 12 Newton. Okay? If the angle between them is 60 degrees. Okay, so the angle between them is 60 degrees. So let me just draw it. But if you don't want to start drawing and doing rubbish, just apply this formula, you get your answer straight. But let me just draw it for teaching sake. So I will now just draw this and draw this. This is 60 degrees. The first one is 10, while the second one is 12. Okay, now let me draw this one this side. It will go like this. Draw this one the other side. It will go like this. Okay, so if here is 10, here is 10. If here is 12, here is 12. Okay, now you extend this side a little to give you that if here is 60, here must be 60. And if here is 60, you say 180 minus 60, you are getting here to be what? 120. And then they say that the resultant of this vector must pass in between them. This is how the resultant must be. This is R. So you are now talking about a triangle that is like this. Okay, a triangle that is like this, and I'm having that here is 120, here is 10, here is 12, and here is R. So if you now apply, if you look at this triangle, you see that this triangle has two sides and one angle, and that angle is in between the two sides. So you are going to use cosine rule. If I use cosine rule, I'm going to have that R squared is equal to 10 squared plus 12 squared minus 2 times the same 10 times the same 12 cos that one in between 120. So I'm having that R squared is equal to, because of time's sake, if you do everything, you are getting 364. Okay, so R is now the square root of 364. So R is equal to 19.08 Newton. Okay, so that is that. You see, it's very, very simple. So let us do another one. Then this one we're going to do, I'm not going to draw it. We are going to use the formula to solve it. You can draw it yourself. We are going to use the formula to draw to solve it. They said that two vectors 5 Newton and 7 Newton, okay, are inclined at an angle of 120 degrees to each other, then they say find the magnitude of their resultant. Okay, solution. So just know the formula. The formula said that what? Just say that the first one, A, is 5 Newton and B is 7 Newton. And my theta is what? 120 Newton. And the formula said that what? The resultant is equal to what? A squared plus B squared. Sorry, resultant squared is equal to A squared plus B squared minus 2 the same A, the same B, then cos what? Cos 180 minus that theta. As simple as that. Once you know this formula, you are done. So let us substitute. R squared is equal to 5 squared plus 7 squared minus 2 times the same 5 times the same 7, then cos 180 minus 120. So what am I having? R squared is equal to 25 plus 49, okay, minus 10, 70 cos 60. So if you do everything, you are going to have 39. So R is now equal to the square root of 39, and square root of 39 will give us 6.2. You see, it's very simple. So the next thing we are going to talk about is now resolution of vector. How do you resolve vector? How do you resolve two vectors? Resolution of vector. Okay, that's the next thing we are going to talk about. Resolution of vectors. Okay, now anytime you want to resolve two vectors, you are asked to resolve two vectors. Now you will be interested in where the angle is. Watch me now. If I have this now, I have this, and I have a vector here, f. This is vector f. Okay, you know that this one is the y-axis. This is f of y-axis, and this is f of x-axis. Now the problem students do have is that they crammed it. They crammed it and said that if it is y-axis, it will now be sine. If it is x-axis, it will now be cos. Please, it doesn't work everywhere. It doesn't work everywhere. You will be interested in where the angle is. For instance, now let me say that my angle is here, theta. Now you are going to use an acronym that said all St. Stephen College. All what? Saint Teresa, not St. Stephen. All St. Teresa's College. All St. Teresa's College. If you can remember this ASTC, you are done. What does it mean? It means that what? It means away from this angle. If you are resolving away from the angle, use sine. So away from the angle, we use sine. But if it is towards the angle, you use cos. If it is towards, please note this thing, use cosine. Okay, please note it. Now if I am resolving this f to this x-axis, I am going this way. Am I going towards this angle, or am I going away from the angle? You see, I am going towards the angle, and towards the angle say I should use cos. That is why you have that f of x is equal to what? The force f sine what? Sorry, cos, not sine. Cos theta. Okay? Now, why did I use positive f? I use positive f because we are in the right side of x. And if we are resolving this left side, I'm going to say that f is minus. It will now be minus f cos theta. Are you getting it now? So look at for y. If I'm resolving y now, for instance, where is my angle? This is my angle, and I'm resolving to the side of y. Am I going against or away from the angle or towards the angle? You see, I'm going away from the angle. I'm taking this thing, this f, I'm shifting it so that it will not enter here. So I am moving it away from the angle. So what am I going to use? I'm going to use a sine, because away from the angle, use sine. So I will say that what? F sine what? Theta. Now, why did I use plus? I use plus because this is up. If the y is up, use plus. But if the y is down, use what? Minus. According to your graph, how do you plot a graph? This is positive y, negative y, positive x, negative x. So anything that happened up here must be positive. Anything that happened down here must be what? Negative. And anything that happened in the right hand side must be positive. Anything that happened in the left hand side must be what? Anything that happened in the right hand side must be positive. Anything that happened in the left hand side must be negative. So thank you very much for watching. In the next video, we'll solve question on that. Okay, let's continue. I just checked my camera. Sorry about that. Okay, so let's solve some question on that so that it will help us know what we are doing. Okay. Okay, let me just give you everything. Then we'll now start solving questions. Okay. Now the next thing we're going to do is resolving vector more than one vector, 2 and above. Let me have this. I have this now. Okay. And I want to resolve this one. This is the first force F1 and is here theta 1. Okay. And this is F2. Okay. Theta 2. This is F3 and theta 3. This is in fact, let me put this one this side. Okay, or let me leave it. This is theta 4 F4. Now we want to resolve this thing into 2 components. The first component is the x component. Let's resolve the x component. S component. So if you want to resolve the s component, now anything that is in the x-axis, okay. So now watch the first one, the f component F1. Now are we resolving? We want to resolve it to x. Anything we are resolving to x. Okay, so we are resolving this thing to x like this. Is it towards or against? It is towards. So if it is all St. Teresa College, so towards is cos. So it will be F1 cos theta 1 plus, let's go to the next one. We are resolving this one now to x-axis. Look at it. We are resolving it to x-axis. Since we are resolving it to x-axis, is it towards or against? It's still towards. So it will now be what? But it is in the left hand. Look at it. It is in the left hand. So I'm going to say what? Minus F2 cos theta. Are you getting theta 2? Okay. Plus the next one, this one. Are we resolving it towards against? If you look at it towards, we are resolving it towards theta 3. So I'll say, and it's still in the left hand side. So I'll say plus minus F3 cos theta 3. I hope you are getting it. Then plus finally the last one. Look at this one. And it's still towards, so and it's in the right hand side. I will say F3 F4 cos what? Theta 4. You see, that is that. So but for y component, look at y component. Y component is equal to, look at, let's do y. You want to resolve F1 to y. Is it towards or against? You see, it's against. So since it's against, I'm having that what? F1 sine theta 1, because against is sine. Plus, look at this one. Is it towards or against? It's still against. So I'm having what? F2 sine theta 2. I'm using plus because all of them are still at the positive y. So let's come down to negative y now. F3. It will now be what? Plus minus F3 sine theta 3. Please don't put it in your head because everything in s-axis is cos. That I'm going to be using cos. No, please. It's because of the way this angle is. Please. Okay. So plus finally minus F4 sine theta 4 because it is against. Okay. So now if you get all these things now, the resultant of it, okay, the resultant of it is that same method of Pythagoras, which is this theory is equal to what? The summation after adding everything for x squared plus after adding everything for y squared. So now, and the angle, their direction will now be tan alpha will now be what? Y first before x. How do I use to know that it is y before x? Because tan means slope and slope means change in y over change in x. That is how you know that y will come first before x. Okay, so then the angle you are looking for is now what? The tan inverse of the summation of what you got in y over the summation of what you got in x. You see, as simple as that. It's not difficult to get. So let's solve some questions on that, then we are good to go. Let's solve some questions on that. Okay, so the first one said we should resolve example 1. Example 1 said resolve the force shown below. Resolve the force shown below in its two components. In its two components. Okay? Or in its perpendicular, in its two parallel, in its two perpendicular components. Okay, so what do you do? Look at the force they gave us. They gave us these two vectors like this. Okay, they said that this is the force 10 Newton. 10 Newton. Okay, and they gave us that here is theta, and the theta is 60 degrees. 60 degrees. Okay, so now, look at what I'm now telling you. Look at what I'm telling you. Now, if I want to, don't forget, immediately you see this type of thing, the first thing you will write is what? All St. Teresa's College. Just write this thing out. You will now know what you are resolving. So for y component, f of y should be equal to what? Now, y, are you going towards or against? You see, I'm going towards this. So towards is cos. You will now see that you're having what? F, which is this force. F cos what? Theta, which is what? 10 cos 60, which is what? 10 times 1 over 2, which is 5 Newton. You see, this is y-axis, but we used cos. Why? Because it is towards. So please, don't assume that y is sine and x is cos. Always use where it is going. So look at our x. F of x should be what? F, you see, is against. Is against. And what? Away or against. Away will give us sine. So I use what? F sine theta. So what do we have now? We are having 10 sine 60, which is what? 10 root 3 over 2, which is 5 root 3 Newton. Okay? So that is that. And simple as possible. Okay. So example 2. Example 2. Now for example 2, we have let's say by resolution or otherwise calculate the value of the tension T in the figure below. Now we have this. Okay, and we now have we have these two. Okay, they say that here is 30 degrees, and here is 30 degrees. Okay, now here is 20 Newton. Okay, they say we should find this tension T. Okay, solution. Now, if we want to resolve this, look at it. We are having this like this. Now, note that this thing is bent this way. This tension is bent this way. We want to resolve it directly like this. Okay, and resolve this one directly like this. Okay, don't forget, because we always resolve in 90 degrees. Okay, so and I have a force like this. This force is 20 Newton. Okay, so if you want to resolve this, what do? Don't forget that this is our Ty and our Ty. Okay, so now how do you do it? Now note that Ty should be equal to what? This tension resolved this way. And look at the angle. The angle here is 30 and the angle here is 30. Is it towards or against? You see, it's against. Or away. Is away. Since it's away, what am I going to use? All St. Teresa College. So I'm using cos. Sorry, away is sine. Away is sine. So I'm using sine. It will now be what? T sine 30. This T you are resolving sine 30. Okay? So now the other ty is the same thing, so they are two. The other ty is the same thing, t sine 30. But there is a law that said that upward force supposed to be equal to the downward force. So this force now, this force 20 supposed to be equal to ty plus ty. Are you getting it now? So I'm having a what? 20 is equal to what? This is 2ty. Okay, so I'm having that what? Ty is equal to 20 divided by 2, which is equal to what? 10 Newton. Okay, 10 Newton. I've gotten my ty to be what? 10 Newton. Okay, now to get my t, watch now. I've gotten my ty. So to get my t, I know that my ty is equal to what? T sine 30. So this is what? 10 Newton is equal to what? T sine 30. So t itself should be equal to what? 10 over what? Sine 30. Is it not? So the t I'm looking for is what? 10 divided by 0.5, which is equal to what? 20 Newton. So I have gotten it. 20 Newton. So that is my t. But if you don't want to solve it this way, that is for resolution, the way you resolve this thing. If you don't want to solve it this way, let me decide to trace this man like this. So I'm going to have a triangle that's shaped like this. Look at the triangle. Alternatively, here is my 20 Newton. Here is my t I'm looking for. And here is what? 30. And don't forget, this is right angle. So I'm going to use SOHCAHTOA. Opposite over hypotenuse. So sine 30 is equal to opposite 20 over hypotenuse what? Hypotenuse t. Are you getting it now? So what do we have? We now have that t is equal to what? 20 over sine 30, which is what? 20 over 0.5. Which is equal to what? I'm having 40 Newton. So how did we get 40 Newton? Okay, this is 40 Newton and it's for the two of them. Okay, it's for the two of them. So 2t is that 40 Newton. So t is now 40 divided by 2, which is 20 Newton. Okay, so that is that. Because you cannot use this if you want to. Why did we use 2t here? Because this force now, if you apply it here to draw this, is affecting the two of them. Okay, so it's for the two of them. So that's why we use that. So we got 20 Newton. But the best way to do it is by using a resultant of resolution of two vectors. Okay, so let's solve more problems on that. Okay. Okay, they say calculate the, or let me do this one. They say calculate the resultant of 5 coplanar forces of value 10 Newton, 12 Newton, 16 Newton, and 20 Newton, acting at 0 as shown below. So I'm having something like this. This is the first one, 10 Newton. This is the second one, 12 Newton at an angle of 50 degrees. This is the other one, 20 Newton, making an angle of 40 degrees here. And the next one, 16 Newton, and this one, 15 Newton, making an angle of 30 degrees. Okay, Let me put this on to 60 degrees. Okay, so in our next video we solve this. Okay, thank you very much for watching. Bye bye. Please don't forget to subscribe.